Hi everyone, hope you all are seeing my channel regularly, practice regularly and doing and giving your best work to yourself, right? So let's start with our new session. In this session, we will practice one more example based on case 2. Okay, as we did one example in our previous session. Okay, then let's start. Okay, uh, see the second example. Here it is given, solve in series, or else we can say that in another words, find the series solution by using Frobenius method or by using singular points for the polynomial x into x minus 1 y double dash plus 3x minus 1 y dash plus y equals to 0. Okay. Before starting this, let's start. I'm just giving overview. In first examples, what we did, right? So first, basically you have to find its p of x, q of x. Then after, in the denominator you have to put x equals to 0, whether uh, and you have to check it is being 0 or non-zero denominator, right? So whether it is being a 0 denominator, then it will be singular point, and if it will be non-zero, then it is said to be a ordinary points. Okay, so first step, you have to check whether it is ordinary or from singular point. Okay, then after you have to write its solution, and that will be into the either k form or into the n form. Okay, then after you have to put all the values in the main equations in your equations, right? And then after do the simplification, and then you have to find its roots. Okay, so till that the all cases will be same, as you know all. Okay, then after you have to find the k, and you have to apply both the parts. Okay, so let's start with this example. Okay, so first of all you have to check it is from ordinary point or from singular point example. So it is being here singular points, as I have not written here, but don't forget to write. Okay, so in first step you have to here apply, you have to first find. Okay, so then after you will find its series solution. So here it will be y equals to summation k equals to 0 to infinite x to m plus square. Okay, now then after you have to find y dash and y double dash as it is given into the equation. So first find y dash and y double dash. So y dash will be, as you know, that will be m plus k x to m plus k minus 1, and for y double dash it will be m plus k minus 1 into the x to m plus k minus 1. Okay, so now putting these all the values in the first equation in your equation. So first term keeping as it is, I'm just opening this bracket, so it will be x square minus x. Okay, y dash, that you know very well now, plus 3x minus 1 keeping as it is, again y dash we have already found, and y that we have already found its solutions. Okay, now in the first step, so see the Frobenius method as we did in our first or second session. Okay, so in first step, if in the polynomial it's given any kind of bracket, then first we have to open it. Okay, so see here x square minus 1 is given. Okay, so first we have to open it. So opening the brackets x square minus x, so it will be x square into this whole term, and minus x into the again this whole term, right? Plus see the second term, here again it is given a bracket, so 3x into this whole term minus 1 again this whole term, and plus y, just keeping as it is. Okay, in next step, and this step I have not written, so don't forget. Okay, now x square into the this term, right? So that will be x square, and here it is m plus k minus 2, so minus 2 plus 2 cancel. Okay, so that will be only this whole term and x to m plus k. Okay, now second term is given your minus x into this whole term. Okay, so again see here that x having single power, so here it is given now m plus k minus 2, so it will be m plus k minus 1. Okay, now see the third term, 3x into the this whole term, so 3x having single power, and here it is given m plus k minus 1, so it will be 3 as it is, ck m plus k, and here it will be m plus k only, right? Now minus 1 and this whole term, So that will be as it is, and this last term again keeping as it is. Okay, hope you understood this step. Now in the next step, what you have to do, that you have to find its similar power. If it is, then first pick out the common. Okay, so see the next step. So see the last step. There is two terms that having single power, that m plus k, and again two terms that having m plus k minus 1 power. Okay, so first I'm writing with access to m plus k power. So see the first and the third term that having, sorry, there are three terms that having similar power. I'm so sorry. So see the three terms that having m plus k power. So see, that is first term, third term, and the fifth term, right? So from the these all the terms, summation is common, ck is common, okay, and access to m plus k is m plus k is common. So rest of the term I'm writing. So it will be, see the first and third term, m plus k is common. So it will be m plus k into the m plus k minus 1. From the third term, plus 3, m plus k minus 1 plus 3. So it will be m plus k plus 2. So I have written here 2 from this first and the third terms. Now see last term that having m plus k power. There is no coefficients, there is nothing. So it will be only 1. So here it will be 1 only. And whole term that having common power, common term that access to m plus k. Now again we having two terms that having a similar power, that m plus k minus 1. So from these two terms summation is common, ck is common, m plus k is common, and the access to m plus k minus 1 is common. So the remaining term I am writing first. So it will be m plus k minus 1, m plus k minus 1, and here it will be m plus k. So it will be, so from these both the terms m plus k is common, and the remaining term will be m plus k minus 1, and here it will be, see here the second term having a negative sign, right? So it will be all the terms negative. So second term will be m plus k whole square, and the rest of the remaining term, that ck access to m plus k minus 1. Okay, now see, now you have to, in the third step you have to make a similar power. Okay, so see the here given access to m plus k and access to m plus k minus 1. Okay, but before this I'm just giving the simplification of first term, that is that having access to m plus k power. Okay, so whole bracket, opening this bracket, I'm just multiplying this whole. Okay, so that will be actual m plus k plus 1 whole square. It is same like a plus b plus c whole square. So it will be a square plus b square plus c square plus 2ab plus 2bc plus 2ca, like this way. Okay, so first open this bracket, and that after you can get this term, that m plus k plus 1 whole square. So rest of the terms again I am writing as it is here, minus second term, that keeping as it is only. Okay, now you have to make a similar power. Okay, so see the last one, m plus k minus 1. Okay, so I'm converting into the first term into the same power, that m access to m plus k minus 1. So in place of k we have to put k minus 1. Okay, so see the first term here, k equals to k minus 1 equals to 0. So it will be k equals to 1 to infinite, m plus k. In place of k we are writing k minus 1, so it will be m plus k only and whole square. C k, in place of that, that will be c k minus 1 access to m plus k minus 1. Okay, now next see both the terms. This one term I've written here. Okay, so don't forget. Okay, now see both the terms, we make a similar power, but see the limits, these both are different. Okay, so first of all you have to do a similar limits. First limit is starting from 0 to infinite, and the another one is starting from k equals to 1 to infinite. Okay, so which one is a common limit? That will be 1 to infinite. So from the first term we will write that having a k equals to 0 terms. Okay, so in place of k I am putting k equals to 0, so it will be m square c minus यहाँ पे, so just keeping as it is, m square c0 access to k0, so that will be m minus 1. Okay, now next it will be this one, k equals to 1 to infinite. I've written here one more term. Okay, so that will be this one, m plus k whole square ck access to m plus k minus 1. Okay, plus last term just keeping as it is. Okay, now again first term as it is, and from this both the terms again I am taking a common terms. So summation k equals to 1 to infinite m plus k whole square ck minus m plus k whole square ck minus 1, and the whole bracket over, then after access to m plus k minus 1. Okay, now it's, now you have to roots. So for that you have to apply, you have to equate the terms. Okay, so here it is two terms, right? So first term and the second term equals to 0. So first term is minus m square into c0 equals to 0, so m equals to 0 comma 0. Okay, when c0 is not 0, so then and only then that will be m equals to 0 comma 0, and the second term equals to 0, and from this always we are going to find ck only. So right, so ck equals to ck minus 1, these both will be cancelled out. Okay, now the remaining part, this part is, again I am telling you, this part is similar till for all the methods, case 1, case 2 and case 3. Okay, till this part. Okay, now part 1 and part 2. Part 1 is again same, that is same as case 1. Okay, so applying m equals to 0, so put k equals, sorry, m equals to 0, but here there is no m, so it will be only ck equals to ck minus 1. Now you have to apply where k is greater than or equals to 1. Now you know this one very well. Okay, now applying one by one all cases for k, so k equals to 1, then c1 equals to c0, k equals to 2, then c2 equals to c1, but what is c1? That is c0, so c2 equals to again c0. So similarly apply this one. So at the last we have to find its series solution, that y1 equals to this one access to m1, yani ki m summation k equals to 0 to infinite ck access to m. Okay, m is 0, and again expand, do the expansion of this series, right? So this one will be c0 plus c1x plus c2x square up to the so on. So in place of c1 c2 all the constants, put the values actual that we have found right now, right? So putting this all, finally we will get this term c0 into the bracket 1 plus x square plus x cube plus up to the so on. Okay, now next part 2. As you know the equations, y2 equals to y1 log x plus x is to m, k equals to 1 to infinite del ck upon del m, that is at the point m equals to 0 into the xk. Okay, so very first we have to find ck. So for that applying ck equals to 1, 2, 3. Okay, so that will be ck equals to ck minus 1 only. Again this one is no need to write, so it's okay, you can avoid it. Applying k equals to 1, so it will be c1 equals to 0. Applying k equals to 2, so c2 equals to 0. At the end you have to find nth term of ck, so that will be ck equals to c0 into c0 up to the so on. Okay, now as you know, first we have to apply log on both the sides, so it will be log ck equals to the derivative of c0, that will be 0 only. Okay, so this whole term will be 0. Now applying partial derivative on both the sides, so here it will be 1 upon ck into del ck upon del m equals to 0. Applying ck on that side, okay, so that will be del ck upon del m equals to 0. So at the last, at the point m, again that will be 0. So see here, applying this whole term will be 0. Applying this term here, so this whole term will be 0. So at the last the remaining term will be y2 equals to y1 log x. Okay, and at the last we have to find its general solution, and that is y equals to ay1 plus by2. So applying this both the values over there, you can find general solutions. Okay guys, one more example is remaining, so that will be do it in our last next session. Okay, thank you.